This is Algebra 2, Chapter 0, Section 5, in which we will be adding probabilities. Before we can add probabilities, we need to know what one is. Probability of an event is just a measure of how likely it is to occur. Probability always has a value between 0 and 1 if you're using fractions or decimals. And it's a value between 0% to 100% if you're a percent user. There are two different kinds of probabilities. The first kind is called theoretical probability. And it's a measure of what could happen, what the possibilities are if you were to conduct whatever your probability is about. An experimental probability is a measure based on what actually did happen. And we'll be asked to distinguish between those two. So let's consider this situation. We have a regular die, and the results, when we rolled it, are in the list. So we rolled this thing, we got a 1 9 times, we got a 2 12 times, and so forth. So the question is, what's the experimental probability of getting a 6? Well, first we need to know how many times we actually rolled the dice. We rolled the dice 9 plus 12 plus 6 plus 6 plus 7 plus 10, and my calculator tells me that's 50 rolls of the dice. Out of those 50 rolls, 10 of them are 6s. So the experimental probability for a 6 is 10 out of 50, which reduces to 1/5. Or if you're a decimal fan, that would be 0.2, or 20% if you're a percent user. Now compare that to the theoretical probability. Theoretical probability of getting a 6. How many possibilities are on a 6? Or on a die? There are 6 of them. Out of those 6 possibilities, one of them is a 6, so the probability is 1/6, or if you make it a decimal, it's 0.167, or 16.7%. Now that's just a simple event. That's only one thing happening. Most of the problems are going to involve what's called compound events, where you have 2 or more things going on. And to find these probabilities, we add together each thing separately and then subtract out any overlap that there may be. You don't want to double count things. So consider, if you will, a deck of cards, standard deck of 52 cards. If they ask us to find the probability of getting a 4 or getting a club, we would need to find the probability of a 4 and find the probability of a club and add those together. But then we have to subtract out the 4 of clubs because we counted it twice. We counted it as a 4 and we counted it again as a club, so we would need to subtract it out. If you don't have any overlap, you call that situation mutually exclusive. And if there is an overlap, your book calls it not mutually exclusive. You may hear the term from time to time, mutually inclusive. So they're going to ask us to determine if what we're looking at is mutually exclusive or not, and then find the probability. So our friend Keisha has a collection of sports cards. She's got 8 baseball cards, 5 football cards, and 6 hockey. If she picks out a card at random, just reaches into the box and pulls one out, what's the probability that it's baseball or football? Well, first we need to decide if it's exclusive or inclusive. It tells us that none of the cards are for multiple sports. We don't have Bo Jackson in here. So this situation is mutually exclusive. You don't have overlap to deal with. If it's exclusive, all we have to do is add the possibilities. She has a total of 19 cards. 8 of them are baseball. 5 of them are football, so there's a total of 13 cards that match the problem. 13 out of 19 would be the probability, which divides out to 0.684 if you want to use decimals, or 68.4% if you use percents. This was an exclusive case because nothing matches. Nothing overlaps. Now consider this situation. Suppose you're looking at a big school with 1,400 students. Now, of those students, 550 of them take Spanish, 700 take biology, and 400 take both classes. Okay, we want the probability that a student that we just picked the name out of a hat takes Spanish or biology. If they take either class, then we count that person. So we need to find this probability. Well, to get there, we need to decide first if it's overlapping or not. Is it exclusive or inclusive? Are there people that take both classes? Yes. Students can and in fact do take both classes, so this is not an exclusive situation. So we're going to have to subtract some overlapping. Okay. So let's count how many kids we're interested in here. We have 550 who take Spanish, plus 700 more who take biology. So there's 1,250 students that are in the 2 classes. However, we've counted 400 of those kids twice. We counted them in the Spanish group and we counted them in the biology group. So we've double counted those people. So we need to subtract them out. That leaves 850 students taking either class. They told us there were 1,400 to start with, so 850 out of 1,400 reduces by my trusty calculator to 17/28, or 0.607 if you're a decimal fan, or 60.7%. So we're looking at adding probabilities today. You have to look for the overlaps. Make sure you take out the overlaps if you have not mutually exclusive situations. And make sure to know whether you're talking about experimental or theoretical probability also. And if you had any questions, as always, hopefully you wrote those down, and we will see you in class.